How you doing, everybody? And welcome back to another episode of Office Chronicles. Nah, but for real, today we're here to build a shift register circuit. So first things first, you're gonna need 2 chips. All right, they're gonna be the 7495s. So that's the first thing you're gonna do. You're gonna go ahead, put that on the breadboard like so. All right, next thing you're gonna do is you're gonna want to put power to them. So go ahead, put the cords in there, you know what I'm saying? Power to pin 14 on both ones, and ground to pin 7. That's how we're gonna do that today. So once you have that set up, then you can move on to the next part. Now the next part in particular isn't all that difficult considering what all you're going to be doing. But at the same time, you always want to make sure that everything is set up right. So the next part is you're going to have 4 inputs. So input A, B, C, and D. And they're going to be the same for both chips. So the first thing you're gonna do, if you don't already, is print out the chip diagram, like so you know exactly where everything is going. Now, so for input A, we're gonna represent it by using the yellow right here. Okay, so for input A, we're gonna plug it up to pin 2. Input B will represent input B with the white wire. Input B, we're going to plug input B into pin 3, like so. Input C, which would be green for educational purposes, of course. Green will be pin 4. And then finally D, which would be blue. That'll be in pin 5. Okay? And that's just your first set of inputs. You will also do the same thing with the second chip. So once you repeat that process for the second chip, it should look something like this right here. So yeah, once you're done with that, it should look a little something. So far, it should look a little something like this. So far. Okay? Next, you're going to have your mode control, your pin 6, which is going to go out to the to the SO out. So for that, you're going to need a power horn on one end. So power on the one end, and then ground plugged in to another. And in the middle there, that's going to be your switch. It's going to be your mode switcher. So then you're going to plug this up into pin 6. And for this particular one, we're going to use orange wire just to make it easier. So you're going to plug it up to pin 6. And they're both going to be, and then once you plug that up to pin 6, you need to then connect both pins, or both pin 6s to each other. That way they can switch modes and it not be a problem. Okay, once you set that up, now you're ready for your outputs. Your outputs, so important. It's really not going to be too bad. So output A, again, A, yellow wire, will be going into the logic probe. But it's also the wire coming from pin 13 will be QA, or output A. Okay, then B, which is pin 12. Again, excuse my voice. Allergies are really kicking my butt right now, so my voice sounds really nasty. But yeah, I digress. So pin 11 will be QC spot. Now QD is a fun one, because now for QD, you're gonna have QD's output go 2 places. the first thing that's gonna happen is QD in the leftmost pin. QD will connect from the first chip to the second. So what that'll look like is QD will not only have its own independent output, but it'll also be connecting to the serial input into the second chip. And the serial input being pin 1. Now when that is done, you repeat the same process for the second chip, except this time QD is just going straight to the output. Not all that bad. Again, pretty straightforward process. There's really not that much else to think about it. It's just get it done. I do advise that you be careful though, where exactly you plug up your wires and how you do it. Orientation is by far the most common mistake in this particular lab. I myself spent a good 40 minutes having to redo this lab simply because I messed up my orientation with most significant bit. So when you put this on your logic probe, QA from pin 1 will be output 7. So it'll be B7. Yeah, B7 to B0 is how you're going to do it. So A of pin 1 will be B7 and A of chip 2 will be B5. Well, 7, 6, 5, 4. I'm sorry, 3. B3. All right. Now, I'm sure you're wondering, okay, but where is the serial input for pin 1? Or rather for chip 1. Pin 1, chip 1. That is just going to be, again, we said most significant digit. So it's going to be your leftmost input. It's going to share. And you're just going to go ahead and plug that up into your pin 1. Now, pins 8 and 9 should be the only ones not plugged up yet. And because of that, you're going to connect them. You're going to connect the pin 8s to each other and the pin 9s with each other. So pin 8 with pin 8, and then pin 9 with pin 9. Now once you get that, you connect the two on both ends. I'll connect them using a red wire. So you'll connect the two on both ends. That way, now all you need to do is take one wire, another wire, from one of them and input it into your debounce button. Now what the debounce will do is it will trigger the switch. So if you've done it right, your wiring, at least, should look something like this. I know it's hard to tell, but everything's wired up. I promise you. Now, in terms of actually getting your circuit to work, at this point, everything should be lit up. You should check your logic probe. Every output should have a light on. Now, what you're gonna do is, when it's 0, or when the button on the switch is under the ground, that means it's 0 and it's right side mode. Then that means all you have to do is hit S7, or because it's your leftmost or whatever button you put as your serial input, you're gonna click that button and your debounce will light up. So normally on the logic probe, it'll be neon green, yellowish. So for this, it'll be yellow, and then every time you hit the debounce button, it's gonna glow from the left side going to the right side, and it's gonna glow red. And if you do it in parallel, you actually have to put down which inputs you want to be active, and then once you hit the debounce, they automatically come on. Thank you for your time. My name is D'Angelo. I hope you enjoyed this video.